In the previous sections, we've learned how to solve quadratic polynomials, namely trinomials, using a method called the quadratic formula method. And we said that the quadratic formula, or we've seen how the quadratic formula will give us our solutions no matter what type they are, whether they're real, whether they're complex, whether they're a simple solution, or whether they're an imaginary solution. The quadratic formula is one of those methods when solving quadratic equation that will give you your solutions no matter what type they are. However, the quadratic formula, it's sometimes can be a little bit long of a method to use, so we want to also consider other more efficient methods that will be able to provide us with the same solution in a shorter period of time, especially when we're up against time, like when we're working on a test. The method that we're gonna look into today is the factoring method for solving quadratic trinomials. And there are many methods to solving quadratic trinomials. We're going to look at just a few of them. I'm going to show you the systematic method. There's the scissors method, which is also known as the trial and error method. There is the factoring by grouping method. And again, there are a whole lot other methods. I'm going to show you some really tricky and easy methods once we get into the discussion. This particular section, we're going to learn how to factor trinomials, solve trinomials rather, using the factoring method, but we're going to put more emphasis on the factoring aspects of it, because once we have the trinomial factored, it is a very simple and easy process to solve that trinomial. It's just a matter of using what we call the zero factor property, which we will see how to use that once we get the factored form of this trinomial. So let's look at the first basic type of trinomials. You're going to be dealing with two types of trinomials pretty much in this section. You're going to be dealing with the trinomials where the coefficient of the quadratic term, or the term that is squared, where you're going to see that coefficient can either be 1 as it is understood or implied to be here, and you're going to see this situation or scenario where it's not 1. It's a number other than 1, whether that number is negative, positive, or whatever. We're going to look at those two cases, when the coefficient is 1 and when the coefficient is not 1. Let's look at the case where the coefficient is 1 first of all. We see that this is a trinomial. It is a quadratic trinomial. First of all, trinomial because it has 3 terms. Quadratic trinomial because the highest degree on the leading variable is 2. If the highest degree was not 2, this would not be regarded as a quadratic trinomial. And what we're trying to do here is we're trying to find a way to take this trinomial and write it as the product of 2 binomials. We want to write it as the product, multiplication of 2 binomials. Binomials, again, 2 terms. So we want to have a term here, a term here, a term here, a term here, and that's going to be the product of these 2 binomials. Well, how can we go about doing this? Again, this is the simplest type, so the process for dealing when the case is 1 over here is very, very simple and easy. Factoring is the reverse of foiling, or it's the inverse of foiling. So when you're thinking about factoring, let's look at when we had a situation where we had to foil a binomial. We said when we multiply this term here with this term here, that was the first term of our resulting trinomial, which gave us, if this was an x here, that gave us an x squared term. Well, you can see here that the first terms here multiplied together is what gave us the first term here. Again, the last term, when we multiplied the last, and I skipped the outer and inner just to illustrate the point, when we multiplied this term here and this term here, that was the last operation of our FOIL acronym, and that last gave us the last term of that multiplied form, or the trinomial. It gave us the last term of that. Well, and then the middle term came as a result of doing the 2 inners doing the two outers and then combining that result? Well, we're going to do the reverse process in this particular section. So here's what we're going to do. We know that the first term of the trinomial always comes by putting something in this position here. And since we're dealing with x, we're going to go ahead and say, okay, well, x here. That will give me my x squared term. So we have x here, x here. Once we put these two x's here, we know that once we do the FOIL, that will give us the x squared term. The last term is not a problem either. We want to find factors of this term here, and we certainly have a few factors of 10. We can use 1 and 10, and then we can use 2 and 5. But we want to find or choose the factor or the pairing in such a way when we combine the products from outer and inner, it gives us this result here, which is this middle term. So we can choose 1 and 10 here, and we can say, well, because this last term is positive, when we combine them, we're looking at a sum that will give us 7. So we want to find factors of 10 such that when we add them, we get 7. This sign dictates what that sentence is going to be. If the sign was minus, then we're going to be finding factors of 10 such that when we subtract them, we get 7. So factors of 10 such that when we add the two factors, we get 7. Well, which two factors over here that are factors of 10, when you add them, you get 7? Well, if you look here, you have 2 and 5. 2 and 5, if we add them, we get 7. So we're going to use those two factors instead of these two factors here. So 2 and 5. Now, we wanted now to consider this sign here. How do we get a positive 7 from just putting signs or combining two numbers 2 and 5? What has to be the sign here? What has to be the sign here? Well, if you said, well, hey, there must be a positive on the 5 and a positive on the 2, so that once we add them or combine them together, we get a, what? A 7, right? So, a positive on the 5, we're combining, positive on 2, in other words, we're combining numbers with the same sign. So, plus has to be on the 5, plus has to be on the 2 in order for us to get a positive 7. So, it's just a matter of putting the plus here and the plus here. So, that's how we factor this simple case. So the simple case, when the coefficient of the squared term is 1, a positive 1 that is, then factored form is just a matter of just whatever this variable is, put 1 here, put 1 here. And to determine what goes in here, we look at the constant term, which is the C term, and we say, okay, I'm going to find two factors of this constant term such that when I, whatever the sign tells me to do, add them, I get this middle number here. And you may want to lay out your factors like this. And then once you determine those two factors, that gives you this middle number here, you want to find the signs or place the signs in the front of them accordingly so that when you combine them, you get this middle term result. And that's just how we do it. Let's look at another example here. So let's take this example. And then we're going to discuss some sign rules. I got some tips for you so that you see what the sign rules are. Let's say we have here x squared minus, let's say we have here negative minus 8x plus 15. Okay? Now we want to factor this. It equals to 0. If we factor this right here, to factor this, what we need to do is set up our parentheses first of all. And again, we discussed and said, and equals to 0 here, we discussed and said, hey, the first term in our parentheses will always be whatever variable that we have here will always be 1 here and another 1 here. The second term is a matter of finding factors of this number But we want to choose the factors such that when we combine the products of outer and inner, that result gave us this middle term. So we know that 15 has a factorization of 1 and 15, and also 3 and 5. Now, some people also regard the negatives. You can do that, but the signs will all work out if you follow the steps I'm pretty much telling you to do. Of course, 15 can be positive 1, positive 15, and also negative 1, negative 15. But we're not going to do that, the negative aspects of it. We'll look into how we take care of that issue, pretty much with the sign. So, factors of 15, 1 and 15, 3 and 5. Okay, which two factors of 15, so I'm looking for two factors of 15, such that when I add the two factors, I get an 8. What are two factors of 15, such that when I add the two factors, I get an 8? That's how we read that statement. Factors of this guy, such that when you either add or subtract, whatever the sign is here, if it's a minus here, then we say such that when we subtract the factors, it gives us this middle guy. But in this case, because it's positive, we're looking for factors of 15, such that when we add them, we get 8. Well, let's see. What are two factors of 15? These are the only factor pairing here. What are two factors of 15 when you add them? Or think of add as you're placing the same signs in the front of them. Think of subtract as you're placing opposite signs in the front of the guys. So, such that when you add them, you get 15. Two factors of 15, such that when you add them, you get, 8. Well, let's see. Oh, wait a minute. If I add 3 and 5, I will get 8. So 3 and 5 are the factors I'm going to choose. Now, here's where the sign comes into play. The middle term is a negative sign. Okay? I want to say, well, how can I add these two numbers or combine these two numbers? What must be the sign in the front of them to produce a result of -8 when I combine them or I sum them? Well, the minus has to be here and a minus has to be there, because when I'm combining numbers with the same sign, what do? I add and I keep the sign. So these two must have both negative numbers in order for me to get a -8. -3 minus 5 is a -8. So we go ahead and whatever the sign is here, and the sign is here, I go ahead and put that -3, -5 here. And I can also check. Let's see. First is x times x. That gives me the x squared. Outer is what? X times a -5. That gives me a -5x. And then the inner is -3x. -3 times x is -3x. I combine those, I get a -8x, so that gives me this middle term here. And now the last is -3 times a -5, that gives me a +15. So it does check. So we've seen how to factor quadratic polynomials where the middle term, where the coefficient of the square term is 1 here. Let's look at another example when this last term is a minus sign. Let's see how that plays out. Let's just change that, and let's change that to a minus, and let's change this over here to, let's see, let's go ahead and do +2. And certainly we could have used a -2 here for illustration purposes as well too, but let's just use a +2. So now we want to factor this guy. So we factor this guy here. First of all, we want to set up our parentheses. And again, squared term here, this quantity here is 2, and that quantity here is 1. I want you to also watch that pattern here, because we can use this factoring method even when this is not 2 here. If it's 4, and as long as this next term here is half, if this power here is half, whatever this power is, we can also kind of use the factor method, but that's going to be later on. So when we want to factor this, we put the x here, we put the x here, and now we're looking in this case, we're looking for factors of 15, such that when I subtract the factors, I get a +2. Or here's another way we can say it. factors of 15 such that when I subtract, remember subtract means I'm placing opposite signs in the front of the two numbers to give this result here. So think again, adding is placing same signs in the front of the two numbers and then combining them to get that middle term. Subtract is I'm placing opposite signs in the front of the two numbers to combine to get this number here. Well, let's see. Again, factors of 15, when I subtract them to get 2, well, what are two factors when you subtract them or place opposite signs in the front of them gives you a result of 2? Again, you will guess that it is 3 and 5. So 3 and 5 are going to be my two pairing here. Now, here's where the middle term sign comes into play. The middle term is positive. What has to be the number in the front of the 5? What has to be the sign, rather, in the front of the 3? What has to be the sign in the front of the 5 in order for me to get a result of positive 2? Well, you would guess correctly to say the 5 has to be the positive, the 3 has to have a negative in it. That gives me a result of positive 2. So, we're going to put just how we have the sign here, a minus 3, and then a 5, plus 5 here. Could we have put the 5 here and the 3 here? Yes, we could, but we want to make sure we're consistent with bringing that sign with it as well, too. So it does not matter where you put the 5 and the 3, but it does matter that you include the sign. If you're carrying the 5 over here, you have to bring that plus 5 here and put the minus 3 there. It does not matter the order, remember, in which the factors appear in a product situation. Remember the commutative property, too. 3 times 7 is the same as 7 times 3. So the factors of this product, it doesn't matter the order in which they're arranged, commutative property. Same thing here. If I put the 5 first here and the 3 there, it doesn't matter because of the commutative property. It's a product. As long as we're multiplying two numbers, it does not matter the order in which they appear. Same thing with quantities. If we're multiplying two quantities, it doesn't matter the order in which they appear.